This is video 4, solving two-step equations. We've been solving one-step equations where you had to make a decision whether you add, subtract, multiply, or divide to solve an equation and get the value of the variable. Now we're going to combine two steps. Two-step equations will look like this example 1. -4 is a constant plus coefficient 7 times x equals another constant 3. The first step is to get the variable term by itself. And what I mean by the variable term is the variable and the coefficient with the variable, in this case 7x. So I look at this and say I want to get rid of the -4 to get 7x standing by itself. I'll use inverse operations just like I did with one-step equations. I will add 4 to both sides. That works because -4 plus 4 is 0, and 0 plus 7x is just 7x. 3 plus 4 is equal to 7. I just turned a two-step equation into a one-step equation, and I'll now solve the one-step equation dividing by the coefficient. So the value of x that makes the equation true is x equals 1. Notice that every line shows what decision was made, and you should have complete equations where appropriate, no loose numbers. Right here, this number plus 4 is just there to show that I added 4 to both sides. This equation has some decimals, and that's okay, because I'll be using the TI Inspire if I need to solve. Nothing else is different. I have the variable on the right this time, so I'm ignoring the left while I make the decision what to do. I see 1.2 times y minus 5.7. So first, I'll add 5.7 to both sides. Now I want to know what number is hidden over here. And now I'm going to add 5.7 to both sides. I'll carry out the operation. That's going to be, it's getting a little crowded here, so I'll skip a line. 7.2 equals 1.2y. These two add up to 0. And that means it's as good as gone. 1.2y plus 0 is just the same as 1.2y. So there's no reason to write that 0 down. Next step is to divide both sides by the coefficient. When I do, the 1.2 over 1.2 cancels out over here. 1.2 divided by 1.2 is 1, and that means I just have 1y. On the right, 7.2 divided by 1.2 is 6. All right, I've got a couple more examples here. This equation, this means the first term right here beats n divided by 7. 2 is being added, equals 2. First, isolate the variable term, and that means the n over 7 part. So I want to get rid of the plus 2. I can get rid of plus 2 by subtracting 2. That leaves me with n over 7 plus 0, and I won't write plus 0. 2 minus 2 is also equal to 0, so in this equation I get I get 0 on the right. That's okay. If 0 was some other number, I would multiply by 7 on both sides, the inverse of dividing n by 7. And I'm doing that here too. It just looks like I haven't done anything, because 0 times 7 is 0. N equals 0 is the correct answer to this equation. The next example, 10 equals 6 minus 2x, is one of the examples that's actually worked out in your textbook. So if you looked on your textbook on page 36, you would see this equation worked out as example 1. There's something special about this one. Even though it's done the same way, sometimes people get fooled. So I'm going to show you how this works. I have 10 equals 6 minus 2x. And always I look for the variable and start working on the side with the variable, making the decision about what to do. This 6, think about it, is this 6 positive or negative? It's a positive 6 that I want to take away. So I'm going to subtract 6 from both sides. Now, if you're looking right here and saying, well, wait a minute, this is a change, you have a minus sign, a subtraction problem, and we're supposed to do the inverse, wouldn't that be addition? No, it would not. The sign after the 6 doesn't change the fact that this 6 is positive. So taking away 6 on both sides works, and I'll prove it to you. 6 minus 6 is 0, and that leaves me not with 2x, but with a negative 2x. For now, understand this. If you have what started out as 6 minus 2x, and now there's not a number here anymore because you subtracted it to get 0, you can now start calling this negative 2x. The coefficient now is negative 2, so divide both sides by negative 2. Notice that when it gets crowded, I skip a line, because I don't want my work all bunched up where nobody can read it. If you turned in work that looked like this, tried to squeeze things into small spaces, it's hard to read. That's poor communication. So use the space you need to use to make your work look right to get full credit. We'll talk some more about the situation where you have a constant minus a variable term. We'll practice it over and over until you get really good at it so you can be straight on when you add and when you subtract. When you're solving two-step equations, notice that this is what I did. I didn't follow the order of operations. I went backwards. In an equation that has multiplication or division and addition or subtraction, I did the adding and subtracting part before I multiplied or divided. I'll show you again. For example, the very first example I did, this means 7 times x, and the inverse would be divide. This means a negative 4 being added, so I did a plus 4 for the inverse. And I did the addition or the subtraction step before I divided by the coefficient. Or in an equation where the variable was being divided by a number and not multiplied by, I did the multiplication step after I subtracted here number 3. Take a look at this one. Subtract, then multiply. So order of operations backwards. That's how you solve two-step equations.